Hi to all. In this video, we are going to see about choice of specific loadings. Specific loadings are there are two types of specific loadings are there. One is specific magnetic loading, another is specific electric loading. Okay, these are the two main things will decide the performance of the machine. Either it may be a transformer, either it may be a DC machine, either it may be a AC induction machine or synchronous machine. This specific magnetic loading and this specific electric loading will decide the design of the machine. So it's very important one. So let me see choice of specific loading. Okay, from the output equation, it is seen that choice of higher value of specific magnetic and electric loadings leading to reduced cost and size of the machine. Okay, but uh, specific magnetic loading. Following are the factors that influence the performance of the machines when we go for high value of specific magnetic loading. Iron loss. A high value of flux density in the air gap leads to higher value of flux in the iron parts of the machine, which results in increased iron losses and reduced efficiency. So when you go for high value of specific magnetic loading, the iron loss value will be increased. At the same time, the efficiency of the machine will be reduced. When the machine is designed for high voltage, space occupied by the insulation becomes more, thus making the teeth smaller and hence higher flux density in teeth and core. So if you go for high value of machines, we need more insulations. That time what will happen? That flux density in the teeth will be more. Transient short circuit current. A high value of gap density results in decrease in leakage reactance and hence increased value of armature current under short circuit conditions. Stability. Okay, the fourth one is stability. The maximum power output of a machine under steady state condition is indirectly proportional to synchronous reactance. If higher value of flux density is used, leads to smaller number of turns per phase in armature windings. This results in induced value of leakage reactance and hence increased value of power and hence increased steady state stability. Parallel operation. The satisfactory parallel operation of the synchronous generators depends upon the synchronizing power. Higher the synchronizing power, higher value higher will be the ability to of the machine to operate in synchronism. The synchronizing power is inversely proportional to the synchronism reactance and hence the machines designed with higher value air gap flux density will have better ability to operate in parallel operation of the machine. So if you want to go for parallel operation, we should increase or the value of specific magnetic loading should be high. But some of the cases here in first point, if we have more specific magnetic loading, what will happen? The losses will be increased, iron loss will be increased. Because of that, that reduce the efficiency. So when you choose that specific magnetic loading, the value will not be go a particular range. Normally, 1.8 burst per meter square is the um, opted value of specific magnetic loading. Second one, specific electric loading. Following are the some of the factors that will influence the choice of specific electric loadings. One is copper loss. Higher the value of Q, larger will be the number of armature conductors, uh, which results in higher copper loss. This will result in higher temperature rise and reduction in efficiency. So when you go for high value of specific electric loading also makes the uh, efficiency reduced, okay, because of higher temperature will be generated in that voltage. Higher value of Q can be used for low voltage machines since the space required for the insulation will be smaller. Okay, if you go for higher value for the small machines of if you go for higher value of specific electric loading for a small machines, the insulation needed for the specific electric loading for the machine will be less. So there we can go for synchronous reactance. High value of Q leads to a higher value of leakage reactance and how much reactance reaction and hence higher value of synchronous reactance. Such machines will not have poor voltage regulations, lower value of current under short circuit conditions, and low value of steady state stability limit, and small value of synchronizing power. Fourth one, stray loss will increase when Q strays losses will be increased. Value of specific magnetic and specific electric loadings can be selected from design data books for salient and non-salient pole machines. Separation of D and L, inner diameter and gross length of the stator can be calculated from D square L products obtained from the output equation. To separate, suitable relations are assumed between D and L. Depends upon the type of the generators. Salient pole machines. In case of salient pole machines, either round or rectangular pole construction is employed. In these types of machines, the diameter of the machine will be quite larger than the axial length. Rotor poles. The ratio of pole arc to pole pitch may be assumed varying between 0.6 to zero point 0.7, and pole arc may be taken as approximately equal to axial length of the stator core. Hence, axial length of the core per pole pitch is equal to L by P is equal to zero point 0.6 to zero point 0.7 rectangular poles. The ratio of axial length to pole pitch may be assumed varying between 0.8 to 3, and suitable value for may be assumed based on the designer specifications. Axial length of the core per pole pitch is equal to L by P is equal to zero point 0.8 to 3. Using the above relations, D and L can be separated. However, once these values are obtained, diameter of the machines must satisfy the limiting value of peripheral speed so that the rotor can withstand centrifugal forces produced. Limiting values of peripheral speed as follows. Bolted pole construction 45 meters per second. Dovetail pole construction 75 meters per second, and normal design 30 meters per second. So specific electric loading and specific magnetic loading, we should not go very high value. At the same time, we should not go very low value. If you go for high values, uh, that losses will be increased. So we must be concentrate on that things. Thank you.